Okay, so welcome to this special edition of ABNcast, brought to you from the Farnborough Airshow. You might hear a little bit of noise behind us. That's why we're here. We're here to see some of the most amazing flying machines known to man. And the F-35 is currently doing its bit behind us. Probably one of the noisiest aircraft of the show this year.
For sure.
So bear with us. When it flies past, we'll probably have to go a bit quiet. But joining me is Paulo Colombo, who is he's the global lead for aviation and defense at Siemens. We're at the Siemens Chalet. The chalets are the large exhibitions for the big supporters of the air show. So Paulo, welcome. Thanks for joining us.
Thank you very much.
We're going to talk about technology, because that's what Siemens is. You're a technology company and you're involved in helping the aviation industry to address its issues.
Yeah.
We'll just let our friends... Oh, let our friend do an upside down pass. Tell us very briefly and broadly, what is it that Siemens brings to the aviation industry that is helping it to address the many challenges that it faces today?
Yeah, absolutely. So what Siemens does today is to create a digital backbone that connects all the parts of the life cycle of an asset. So if you take an aircraft, you start with requirements. These requirements are guiding design and pre-design, of course. And then you are moving into simulation and testing. And then from that, you have to manufacture your parts or your airplane.
Yep.
You have to maintain this asset.
We did say it was noisy.
And it will be very noisy because it goes with afterburner.
Yeah.
So, after that, you have to maintain this asset.
Yeah.
And sometimes also decommission it. So we create digital backbone that is connecting every part of this journey in a way that you have a single source of truth, and it's allow you to take very informed decisions. You can take very well-informed decisions at any stage of the process.
Yeah.
And you can also shorten this process because through digitalization, you can actually understand the effect of some of the decisions you are taking on the other stages.
Yeah.
And in this way, you take better decisions before.
Yeah. And the reason that you've got a place in the industry to do this is that the industry itself hasn't developed this sort of seamless approach to the life cycle, has it? It's developed in silos, and therefore you get these moments where the information about a component or an asset, it gets lost or gets disconnected. Yeah.
Yeah. So there are several issues. I would say that all the big companies are building a sort of full digital life cycle. What they are often missing is that it's building.
Showing off now.
Let's try anyhow. What they are missing is the connectivity, the connection between all these parts.
Yeah.
And you are right. There are silos that they are trying to bridge. And what we do is to add them through an open ecosystem. And it means that you can connect not only the Siemens software, but also any other software that you already have. So you can go on using your workflows.
Yeah.
But you have a single sort of truth at the end that is enabling you to really understand what is happening with your full model.
Yeah.
So you create, I would say, a complete digital twin of not only a product, but also a process.
And in order to do this, then they must require a high level of trust, because this does require information and data to be shared across different organizations. Sometimes maybe they even are competitive as well as being cooperative.
Yeah.
So how does Siemens build that kind of trust there? Is it because Siemens as a brand is a third party, has no sort of definitive stake in this, and can come along and be that third party trusted partner?
Well, what we can do is to bridge different silos of information in a way that they could be accessible to some people and not to others. So there is of course, a high level of control of who can access the information, in which form they can see the information. Let's move on.
Get your train of thought back.
Yeah. So the interesting point is that you don't need actually to see the information to take some decision.
Yeah.
The system can access the information, fuse them together in a way that you can take informed decision. I make you an example. So just imagine that in the optimization phase of a component, the engineering team find out that there is a better way to do that, and it could perform better. So they can make a change, but there are some questions. If I make this change, am I still complying with the requirements?
Yeah.
If I make this change, am I adding complexity in the production area? Or am I making maintenance more difficult and challenging and expensive? So what you can do if you have a digital backbone that is connecting all this siloed data is to have answers to these questions without actually accessing the data or seeing the data.
Yeah.
Is the system that is intelligent enough to provide you scenarios and an understanding of what.
Yeah, and that's what the digital twin world is all about. You can do a lot of things in a virtual world you simply wouldn't be able to do in reality because it would be too risky or just not possible.
Exactly.
In terms of scale.
It's even more than that, because if you think about this digital continuity across the full life cycle, at the end you have also the data that are coming from the actual use of the asset. So if you feed them back into your digital twin using machine learning techniques that are part of the big family of AI, what you have is a learning digital twin. So your digital twin is becoming better and better.
Without you touching it, essentially. It's learning itself.
More and more able to predict the behavior of your component or system or system of systems in different situations. So it's really becoming something that is helping you to take very, very informed decisions.
Well, given some of this technology has been around a while and Siemens has worked on it for many years and trying to get it deployed in the industry, how disconnected is the industry still today? How much work is there to do? There's probably never going to be an endpoint to this. It's just going to be a continual development. But how disconnected it is today? How much work is there to do to get to that point where you think that actually the industry is operating more effectively?
Well, the point is that it's a journey, you know, and it's not only a journey that you can say it will finish in 5 years, because the technology is evolving so fast that something that it's possible today was literally not possible 5 months ago. So now we have AI embedded in workflows that are helping companies, for instance, to increase their production rate, increase the quality of the outcome of what they are doing. We are able to deploy IoT in a situation in which machines on the shop floor are pretty old and different from each other. but it's typical in aerospace and defense because we were used to have very small numbers. So when you have very small numbers, you care till a certain extent if you need to do some manual reworking or if your production rate is not very high. But when you start having the requirements of doubling or tripling your production, that's the moment in which you want to be sure that your quality is perfect without any reworking.
Yeah.
It's you have a very low percentage of scraps. You have machines that are able to produce at the maximum rate. You cannot change everything overnight, but through digitalization, you can improve the output of machine. You can look at predictive and even prescriptive maintenance. So we are at the point where we are able to do all of that.
Yeah.
And the industry is following us because it's solving one of the key problems of the industry.
But it was a slightly quieter A350 that just went by, I think. So we shouldn't be too disturbed too much for the next 5 minutes.
By the way, it's impressive how such a big aircraft can be so quiet.
Yeah, especially compared to what we heard before.
Yeah.
Yes, what you're describing there was an industry that's trying to do more with what it's got, because there's only a certain amount of capacity out there in MROs, in OEMs, etc. And that's not going to change overnight, because that's really difficult stuff. So you're trying to be more efficient with the capacity you've got, but you've also got the issue of people as well. So how is AI helping with that kind of challenge, where you've got probably an aging workforce or a workforce that is not as experienced?
We know that this is one of the big problems that we have in the industry. For sure, to a certain extent, automation and AI is helpful in order to not only automate processes, but I would say also to help collecting the knowledge of people. Because if we are talking about learning systems, it means that these systems are becoming able more and more to act and predict. And this is for sure helping companies to keep the pace with the challenge of a workforce that is difficult to find. The other thing is software is becoming easier to deploy and use. So low code, no code systems are designed also to allow an engineer to create a machine learning model without being a super expert. And so without the need for one of the very, very few data specialists that you have in the company. The fact that you have co-pilots into your software is giving you the ability of asking questions and give the very boring stuff to the computer that is managing all of them. So it's saving one of the most important resources that you have in a company, that is the brain of engineers.
There continues to be a lot of concern about handing so much over to the computer to do. There's that concern about what AI ultimately means and how much control, how much trust you can put into AI. Or where do you stand? Where do you stand on that? Are you someone who's quite a sort of
I think
pro AI person?
Absolutely pro AI for many reasons. One is that with the pace of innovation that we have today, and with the challenges that we have to face about complexity, about the workforce, about what the industry wants to achieve in the future on sustainability, you cannot miss the opportunity to accelerate development and looking into the full life cycle like we are doing today. Without AI, it's impossible for people to take into account all the ecosystem that is around an aircraft today. It's impossible to track and take into consideration the supply chain that in the last few years generated a lot of problems on resilience and stability of price, availability of components and raw material. So I don't see that as something that will kill the jobs that we have today. I see that as something that from one side is becoming a companion of an engineer. It gives superpower to these people. And for sure, it's enabling us to think about something that was basically impossible to do before.
The thing with aviation is there's not enough people in aviation anyway. It's not like you're going to get rid of people and replace them with technology. The whole point of this is to, yes, accept you've got the people you've got, but you want them to be working better and more efficiently and more quickly at what they do.
But think also about startups.
So
one thing that's fascinating me a lot is that we have these startups that are coming out of the blue from nowhere. And in a few years, 3, 4, 5 years, they are playing together with the top players of the industry. They are bringing a lot of innovation. How a small company with limited resources can do that? And if you dig into what they are doing, most of them are really relying on the digitalization since the beginning. I call them, a digital native, like the new generation of children. They are born with a mindset of digital first, and what they are able to achieve, it's impressive. We are presenting just in these days with Jet Zero. That is a very good example of a very innovative company that moved very quickly from design phase. They are moving into the pre-production now. We have just launched the news about exploration company. So in Europe, we can have something to compete with SpaceX. Very young company, but already able to create incredible things because they started from scratch with digitalization.
And is it important for you, for a company like Siemens, to support these startups at an early stage to get them through what is obviously always a difficult period when they're trying to make revenue and stay alive?
We have programs to support them, and from one side it's a way for us to support the future of the industry, and on the other side also to learn the different way of thinking that these companies are bringing into the industry. Sometimes trying to break rules and find out that breaking these rules is bringing results. And we are really investing a lot on that side, including the fact that they are already the company that want to see AI applied to processes. And just to give you an idea, as Siemens, we are investing around 1 billion euros in the next 3 years just on industrial AI. Because we know that this is the future of, above all, manufacturing in this moment. We already apply that on design and engineering since a while.
And look, Siemens itself is always growing. You're here in Siemens now because of acquisition. So tell us where you came from originally.
I came from the acquisition of Altair. Altair was a company deeply specialized on simulation AI and data analytics. So the integration of the Altair heritage with the Siemens portfolio is providing something unique that from one side, now as Siemens, we are able to cover all the physics and really working on multi-physical environments when we build digital twins. Yeah. On the other side, Altair had a very long history with AI applied to engineering. So we recently launched the Intelligence X Center. So this is a new platform that is integrated in our digital backbone, and it's enabling company to easily apply AI agents. So this is part of the heritage of what Altair is bringing.
Yeah. Okay.
And the last thing that I think it's important to highlight is that through that we have created something that is very interesting also for maintenance. So here at Farnborough, we are showing an example of a drone that has a malfunction on a sensor. Mm-hmm. So typically, when something like this is happening, you have the drone that is sending a message to a home base, I'm coming back because my sensor is not working anymore. And you have to plan for replacement. So the system is starting telling you, the drone is coming back. Do you want me to look for the parts if it's available for replacement? So you can say, yes, the human is in control, but on the background you have agents, the AI. And this system is starting looking into a network of databases that are connected through our technology. Mm-hmm. So it says, yeah, I identified the part. It takes 3 weeks to have it. I scanned all your suppliers. This is the faster one. Is 3 weeks acceptable? No. Yeah. Do you want me to search for a compatible part? Yes. So it finds the part that is compatible, and it says, okay, you can mount that tomorrow, but in order to do that, you need someone that is certified to work on that specific problem.
Yeah.
You have one person that is now working on another project. Do you want me to move this person to this project? And so you can start having an idea of the complexity of decisions that AI is helping you to take. Yeah. Till the point in which you have everything set up and these agents are, again, scanning all the database and are telling you, by the way, this aircraft is due to maintenance in 48 hours. Do you want to perform maintenance now? You will save X hour of grounding time. Yeah. And just imagine apply that to a fleet of aircraft. So you can really optimize a lot of decisions based on information that are scattered across the full ecosystem that is around your aircraft.
And that really takes you into, you mentioned it before, predictive or prescriptive future.
Yeah, exactly.
Which is something we cover. We run the Predictive Aircraft Maintenance Conference.
Exactly.
Three times a year now. And what we're finding with that conference is that where maybe in a few years ago people were talking about the technology in a principle, we're now seeing case studies emerge of companies and the airlines that are using predictive, and they're coming and telling us what the impact is. So just before we finish up, are we in a period now where we're seeing this technology being applied as opposed to just sort of thought about in an academic way? It's actually it's industrialized, as you said. It's being used, and and case studies are emerging as to what the impact is.
I think so. We went through the academic work, then we had, I would say, the era of POC, proof of concept.
Yeah.
So a lot of companies were trying, but what is always difficult for the industry is to move from the proof of concept to the full scale of operation. And this is what we are now seeing, companies that are already seeing that technology can be reliable and can be applied. And so they start to apply that as it should be.
And that encourages others to follow suit because they see the impact in reality as well.
But the impact is it's really impressive. We have some companies that told us that they are able to reduce their management time of some processes even by 50%.
Wow. Okay. Yeah.
So it's a lot of time. It's a lot of money.
I know you're a busy man, and I think you've got another meeting to rush off to, so we're going to have to finish that there. But thanks very much. I'm glad we got a bit of quiet in the end. Thanks to our friends flying behind us. But thanks very much, Paulo.
Thank you.
On the stand.
It was a pleasure.
Good to see you. Thank you. Cheers.
Thank you.